Good morning, students. We have seen yesterday that where the images are formed when the object is infinity, at infinity, beyond C, at C, C and F, at F and F and P. And in the table itself, I have shown you that what is the position of the image and what is the magnification. And also we have seen a problem, and that problem tells us that here, okay, if the pencil is kept horizontal on the principal axis, what is the size of the image of the pencil? That problem also we have seen. Now today we have to go for the defects or aberrations of the images. Defects or aberrations of the images means we have used the formula F is equal to R by 2 and mirror formula 1 by F is equal to 1 by V plus 1 by U for the what is called as lenses and mirrors. So yesterday we have seen about the mirrors. So using that formula we can find out the image distance, object distance or focal length, all the things. And that formula holds good only for those objects which are close to the principal axis. That formula holds good for those objects which are close to the principal axis. Okay. Now, today we have to go for the what is called as a spherical aberration. In that spherical aberration, I have told you that here the aberrations are based on the following assumptions. What are the assumptions? See, objects and images are situated close to the principal axis. Objects and images are situated close to the principal axis. This is the first point. So what is this point? Here that they are based on means that formula R is F is equal to R by 2 and 1 by F is equal to 1 by V plus 1 by U. That formula holds good for the following assumption that here the objects are or images are close to the principal axis. Second is rays diverging from the objects are confined to a cone of the small angle. Rays diverging rays. Suppose this principal axis. So these are the diverging rays. They will form a cone here. They will form a small cone. This angle is called as a cone. Then if there is a parallel beam of rays, we call it as a paraxial, parallel axial, and here parallel and close to the principal axis. If there is a parallel beam of rays, it is called as a paraxial, and close to the principal axis, paraxial. Parallel beam of rays, paraxial, P-A-R-A-A-X-I-A-L. This is the paraxial. The first point is that formula F is equal to R by 2, 1 by F is equal to 1 by V plus 1 by U. That formula holds good for the objects and images are situated close to the principal axis. First point. And second point is that rays are diverging from the object. They will form a cone. The third one is when the parallel rays are incident on the mirror at that time, they are called as a paraxial rays. Okay. Then after this, we have to go for spherical aberrations. So spherical aberration means a distortion. म्हणजे ते एखादा इमेज जर आपल्याला क्लिअर दिसत नसेल तर त्याला म्हणायचं aberration. And when does this aberrations are come? When the image is not clear. What are the defects we are coming? One is spherical aberration. Second one is coma. Third one is dysmagnetism. You see here. The first one is what's called as a coma, astigmatism, curvature, distortion, and See, when the images are not clear at that time, we are getting spherical aberration, astigmatism, then what is called as curvature, and then distortion, and what is called as a coma. Okay, so we are able to reduce this spherical aberrations. How, what are the spherical aberration? We know that f is equal to r by 2. If the diagram is like this, if we take a spherical concave, what's called as a mirror, a spherical concave mirror. Now here, this is a spherical concave mirror, like this. When this is a spherical concave mirror, at that time, this is the principal axis. Here, and when the rays are close to the principal, this is the principal axis. When the rays are close to the principal axis, at that time, after reflection, when the rays are close to the principal axis, after reflection, they will meet at a point called as a focal point. Like this. After reflection, they will meet at a point called as a focal point. This one and this one. But when the rays are away from the principal axis, they will meet closer to the pole. They meet closer to the pole. म्हणजे असा हा रेस प्रिन्सिपल ऍक्सिस पासून दूर आहे, मग तेव्हा ते इथे येत नाही, तो थोडा असा क्लोज फॉर्म होतात प्रिन्सिपल ऍक्सिसच्या, अपोलच्या क्लोज फॉर्म होतात इमेज. लाईक दिस. हा जो आहे हा रे म्हणजे इथंच आला, त्यांनी ह्याला नाव दिलेलं आहे, जेव्हा टेकन ॲज अ व्हॉट्स कॉल्ड एफ-पी अँड एफ-एम. हा झाला एफ-पी आणि हा इमेज एफ-एम, आणि ह्या पॉइंटला ए म्हटलेले, ह्याला बी म्हटलेले. सो व्हॉट इज दॅट हियर? बिकॉज ऑफ द curvature of the spherical mirror, the rays which are away from the principal axis, they will meet closer to the pole, and the rays which are close to the principal axis, they meet away from the pole. Here there is a gap between this Fp and Fm. Here there is a gap between Fp and Fm, and we call that gap as, you see here, Fm and Fp is measured as a longitudinal spherical aberration. This distance is called as a Fp and Fm. As about the distance, we call it as a longitudinal spherical aberration. Longitudinal spherical aberration. Fp and Fm. Longitudinal spherical aberration. Aberration म्हणजे इमेज क्लिअर दिसत नाही. Longitudinal spherical aberration. Here the distance between them is called as a longitudinal spherical aberration. And here A and B will form a circle. A and B is form a circle. This is in case of the what is called as a concave mirror. In case of the convex mirror also, we can see the spherical aberration. For example, if the convex mirror is there like this, this is a convex mirror, and again This is the principal axis. Principal axis. These are the rays. Close to the principal axis, and here these are the rays which are away from the principal axis. Okay, like this. Now the rays close to the principal axis will meet at a point called as a FP. And here is also the ray after reflection. And the rays which are away from the principal axis, they will meet close to the what is called as pole. This is the pole. They are appear to meet. We call it as a appear to meet. Here FP, here is FM, reflected ray. And these are the points A and B. They will form a circle, and we call that circle as you see here. We get a single point image on a screen perpendicular to the principal axis at the location of the beam of the incident parallel beam. And so these are the incident parallel beam. The rays which are close to the principal axis meet at the point FP. They away from the principal axis meet at the point FM. And the distance between the FP and FM is called as a longitudinal spherical aberration. Longitudinal spherical aberration. At a particular location of the screen, the diameter of the circle is minimum. हा जो सर्कल फॉर्म होतोय हा सर्कल जो आहे तो मिनिमम असतं. कधी कधी हे फक्त दोन रेस इकडून येणारा रेस असा फॉर्म होतो, इकडून येणारा असा फॉर्म होतो. दे विल फॉर्म अ सर्कल अँड देअरफॉर हिअर at a particular location, here the distance is minimum, and this circle is called as a least confusion. And this small circle which is forming by AB is called as a least confusion. So basically remember that here aberration is nothing but the defects which is arising because of the curvature of that what is called as mirrors. Now for that purpose, to reduce the curvature, generally we have to take the parabolic mirrors or parabolic what is called as convex mirror or concave mirror. म्हणजे सर्क्युलर घेण्याची थोडा पॅराबोलिक घेतलं तर aberrations कमी होतात, images clear दिसतात. Okay, so this is about what is called as defects or aberrations of the images. So aberrations of the images are formed because of what is called as the curvature of the mirrors or the lenses. Okay, so here this is the what is called the aberrations in case of the concave mirror. These are the aberrations in case of the convex mirror. But instead of this spherical mirror, if you take the parabolic mirrors, parabolic lenses, at that time the aberrations are reduced. So different types of the what is called as defects are there in formation of the image, like coma, astigmatism, aperture, distortion. Among that, the special is a spherical aberration. So spherical aberration means there it is forming the circle. Here the distance between FP and FM. The rays close to the principal axis forming the image away from the pole, and for rays away from the principal axis they will form close to the pole. And the distance between them is called as a longitudinal spherical aberration. and the circle will be minimum at a particular distance, the circle will be minimum. That circle is called as a least confusion, circle of the least confusion. This is about what is called as a spherical aberrations. And as I told you that the spherical aberrations can be reduced by taking the parabolic mirror or parabolic lenses. Okay? So this is about spherical aberration. Now after this spherical aberration, we'll go for पुस्तकातला पेज नंबर बघा तुम्ही, पुस्तकातला पेज नंबर आहे 164. We'll go for refraction of light. Refraction of light. Refraction of light. Okay. So in the refraction of the light, when light travels from one transparent medium to another transparent medium, it changes its direction. And then the direction changes, velocity changes, wavelength changes. So when at the point of interface म्हणजे दोन medium मधला surface, that is called the interface. At the point of interface, the ray of light changes its direction, and the changes of the direction depends upon the what is called as a density of that medium. When the light ray travel, if you know that when the light ray travel from rarer to denser, it bends towards the normal, and when the light ray travel from denser to rarer, it bends away from the normal. So the quantity which shows the relation between the what is called as two different medium, that quantity is called as a refractive index, represented by eta. Eta is equal to, if the light travels, you know that maximum velocity of the light is in the vacuum. Air is also denser as compared to the vacuum. Water is also denser. But compared to the water and glass, water is rarer, glass is denser. But comparing to air or water, then air is rarer, water is denser. Comparing to the air and vacuum, air is denser, vacuum is rarer. So like this. So refractive index give the value. The refractive index give the value between that value which shows one medium is how much denser with respect to the another medium. More the refractive index, then that medium will be more denser than the other. For example, if c is the velocity of light in air, v is the velocity of light in medium, when the light enters from air to glass at that time, here the light bends towards the normal. So we can say that here refractive index of glass with respect to air is equal to velocity of light in air upon velocity of light in glass. That means we can say that refractive index of glass with respect to air, velocity of light in air, velocity light in glass. Okay. In the 10th standard, you have studied that velocity of light in air is 3 into 10 raised to 8 meter per second. You have to remember this. C is equal to 3 into 10 raised to 8 meter per second. And velocity of light in glass is 2 into 10 raised to 8 meter per second. If you want to find out the refractive index of glass with respect to air, is 3 into 10 raised to 8 divided by 2 into 10 raised to 8. So this 10 raised to 8 get cancelled, so this will be 1.5 is the refractive index. One medium more denser with respect to other medium, then refractive index will be more. Okay. Air is having the refractive index of 1.001 with respect to vacuum. Okay. You know that vacuum or air, actually velocity of light in air is not 3 into 10 raised to 8, it is about 2.99. थोडं कमी आहे. व्हॅक्यूम मध्ये 3 into 10 raised to 8 आहे, परंतु हा एअर मध्ये 2.99 आहे. म्हणून 3 divided by 2.99 means 1.001 is the refractive index of what is called as air. Air is denser with respect to vacuum. But generally 2.99 is equal to the 3, so we consider the velocity of light in air and vacuum as same, that is 3 into 10 raised to 8 meter per second. Okay. So optically denser medium. refractive index are two types: absolute refractive index and relative refractive index. If you are comparing the what is called as a denser with that of the air or vacuum, how much denser one medium with respect to the air or vacuum, at that time we call it as a absolute refractive index. Absolute refractive index. But when we compare the denser with that of the other medium, that is, for example, here refractive index of glass with respect to air, that is the refractive index of glass with respect to air is equal to refractive index of glass with respect to air is equal to 3 into 10 raised to 8 or 2 into 10 raised to 8. Here, this is a what is called as a what is called as a absolute refractive index. This is a absolute refractive index. A relative refractive index means refractive index of glass with respect to water. At that time, we have to take VW upon VG. VW, all of you know that here, how much? It is about 2 into 2.25 into 10 raised to 8. And that of glass is 2 into 10 raised to 8. So this gets cancelled. So 1.1125 is the refractive index of what is called as a glass with respect to water. This refractive index is called as a relative refractive index. एखाद्या मीडियमचा रिफ्रॅक्टिव्ह इंडेक्स एअर किंवा व्हॅक्यूमशी तुलना करत असाल, एखाद्या मीडियमचा रिफ्रॅक्टिव्ह इंडेक्स एअर किंवा व्हॅक्यूमची तुलना करत असाल तर त्यावेळेस आपण म्हणायचं त्याला व्हॉट इज कॉल्ड ॲज अ ॲब्सोल्यूट रिफ्रॅक्टिव्ह इंडेक्स. जर एखादा रिफ्रॅक्टिव्ह इंडेक्स, एखाद्या मीडियमचा रिफ्रॅक्टिव्ह इंडेक्स काढायचा आहे, एका मीडियमशी कंपेअर करून दुसऱ्या मीडियमशी काढत असाल तर त्याला म्हणायचं रिलेटिव्ह. म्हणजे एक नंबरचं मीडियम व्हॅक्यूम किंवा एअर सोडून दुसरं कोणताही असलं तर त्याला म्हणायचं आपण व्हॉट इज कॉल्ड ॲज अ हिअर रिलेटिव्ह रिफ्रॅक्टिव्ह इंडेक्स. Absolute refractive index is always greater than 1. Eta is always greater than 1. Whereas the relative refractive index is here maybe less than 1, maybe greater than 1. If one number medium, if suppose refractive index of water with respect to glass, at that time Vg upon Vw, at that time that value will be less than 1. So, how you are comparing one medium with that of the other medium? One number medium may be denser, two number medium may be rarer. At that time, here the refractive index will be